Hello and welcome to part 3 of the Java REST tutorial series. Today we will be going over a quick review of part 2. Then we will be moving on to important terminology that you will want to know in order to build our REST service. These annotations help direct requests from the user to the proper method or to the proper code. And lastly, we will be doing a coding example of how to connect to a database. In part 2 of the series, the first important piece of code we talked about was adding the XML code to create our servlet. Now I oversimplified what the code does. I just referred to it as the gatekeeper, but it's really important to understand that it does way more than that. This piece of code is what loads the Jersey framework into our application. You can think of it as the foundation in which we're going to build our code on. It handles all of the plumbing, like creating a listener, how to handle all types of HTTP requests, how to route these HTTP requests to the proper method, and also error handling. But that's really what the framework is for. It's to get us away from the plumbing so we can concentrate on what the customer wants and is paying us for. And when we actually need to interface with that plumbing, it's easy to use and it's well defined. That is the hallmark of a good framework. It's not there to make you conform to a specific way of coding, but that's just really a side effect. It's there to allow you to work on code the customer is paying you for. Here is a simple diagram of what we have built so far. From any web browser, we can enter in the URL of our Java REST service. In this example, we are looking for the status resource. Once the HTTP request has been sent, the API will receive the request and start deciphering the URL. In our web.xml file, we specified that any URL with the word API will automatically be routed to our Java code. Since the word API does exist in our example, this request will be routed to our Java code. At this point, the remaining URL string will be deciphered to see if there is a Java class that will handle this particular path. Since we do have a v1/status class, and the method also handles a GET request, this method will execute, and once it's done executing, it will return data back to the browser. This is a basic example of how your REST service or API should react when a request comes in. Now let's take a look at each annotation that we will be using throughout this series. The first one we will be going over is the path annotation. The path annotation is usually where you start when you're building a new class or a method within a class. The path annotation is responsible for routing HTTP requests to the proper method or class. If you're using it at the class level, it's to route them to one or more methods. If you're using the path annotation on the method level, that means you want to route a specific request to a specific method. The path annotation can also be used in conjunction with the @path_param annotation. This will allow some of the URL string to be used inside of a method. We will go into detail on that later on. The next annotation we'll be looking at is actually 5 different annotations, but we will only be using one for each method. Each of these annotations map to an HTTP method, so what is important to understand is that get, post, put, delete, and head are methods within the HTTP version 1.1 specification. So what Jersey is doing is that it is borrowing the naming convention and mapping their annotations to the HTTP method. So the originator of these names is from the HTTP protocol, not from the Jersey framework. Each of these verbs should be designed to be used for a specific action. Now, like what I've said in part 1, these are the recommended actions that you should use the verbs for. It doesn't mean that you have to use it in that specific way, but it is a very good idea to keep with these recommendations. The get annotation is the most used and the most easily accessible of all the annotations. It should only be used to retrieve data, and it should be used only on data that everybody can see. The post annotation should be used for inserting or submitting data. An example of submitting data would be a login page in which you have to submit the username and password. The put annotation is mainly used to update existing data, but it can also be used to insert data. We will go more into this in detail when we get into a coding example. The delete annotation is used to delete or remove data. And lastly, the head annotation is used to return metadata about a resource. An example of this would be on the right hand side of the screen right now. We have a versions resource defined. If we were to create a head method, it would tell the users this method is accessible through a get HTTP request, and it will return the version number of this API. So the head method is really used to tell the user how to access the method and what the method actually does. I personally do not use the head annotation very often. I'd much rather just create a README file in which the users or developers can go there to see all of the methods that are available, rather than making them having to call a head method just to tell them how to use this API. An HTTP request can specify what kind of output it wants. This is where the @produce annotation comes into play. This annotation will specify what type of output a method will produce. When you use the @produce annotation at the class level, it is treated as a default. This is optional, and I tend not to specify a default. If you define it at the method level, it becomes a requirement if you want to execute that method. You can also have a method accept more than one output type. We will go more in detail on that later on in this series. The examples shown to the right are user-defined produce types. In this series, we will be using predefined media types that will do some encoding for us. Again, as soon as we get into the coding, I will explain this more in detail. If we need to send data to the service, there's two ways to send it. One, you can send it as part of the URL string, so you will be using URL parameters, or you can send it in the body of the HTTP request. The @consumes annotation specifies where it's going to look for that data and also what type of data it will accept. It's usually better to send data in the body, but if you use something like a GET request, then you can only use URL parameters. You can also define your own consume types, but in this example, we will be using predefined media types. Again, we will go into more detail on all of this once we get into the coding. Alright, so let's get into some code. In this example, what we're going to be doing is we're going to define in WebLogic the database connection, and then we will reference that in our code. We will still be using a get HTTP request, and we will be producing text/HTML. So the first thing we're going to do is we're going to go ahead and open up Eclipse. This is the IDE that we're going to be using in order to develop our code. That's the directory path that I have been using for episode 2. So we'll just continue on. Now we're going to need access to an Oracle database, and I already have an instance running. If you need to know how to create an Oracle instance using VMware, I do have a video, and you can use that video. You can look at the comments below, and I'll try to put a link in the video. Once Eclipse is finished booting up, go ahead and highlight your WebLogic server. I'll just hit this little button to see that my project's already on the WebLogic server. And what I'm going to do is I'm going to go ahead and start this up. And I'll just wait for this to finish booting. Once your WebLogic server is finished booting up, you can go back to the server tab, and what you'll see is that your project will now say synchronized. So now what we can do is we can go ahead and open up a web browser, and then we can type localhost :7001, and we're going to type console here. And what this will do is this will bring us to a web interface to our WebLogic server. So we'll go ahead and type in our user ID and password. And once we have logged in, we can go ahead and go to this data source link. We'll select that, and this is where we're going to define our database connection, and then we'll reference what we have here in our code. So let's go ahead and push new, and then we can say generic data source. Then we will just name our data source, so we can say Oracle 3082, and then here what we can say is something that this is what's going to be referenced in our code. So something short but descriptive. So we can say 308 tube Oracle, and the type of database that we're going to be using is Oracle. So we'll select next. And what we'll be looking for is the thin instance connection. And we're looking for the non-XA one. So we'll select that, hit next. We will uncheck global transactions. We won't need that for something as simple as what we're going to do. Go ahead and select next. And over here, I've already written down all of the database information. So I'll go ahead and just copy that into here. And then I'll select next again. And right here, we can actually test our connection. And what you should get, if your instance is up and your information over here is correct, is you will get a connection text succeeded. Now you can hit next again, don't hit finish. And what you need to do is you actually need to deploy this to your server. So you have to have this checked, and then you can hit finish. And at this point, this database connection with this ID can now be referenced in your code. So I'll go ahead and highlight this, I'll copy that, and I'll save it off over here. And after that, you can go ahead and log out. That's all we need to do inside our WebLogic server. So the next thing we're going to do is we're going to actually go ahead and start GitHub, because I want to make a branch which will signify the start of this episode. So I'm just going to go in here, and then I'm going to go ahead and say create branch. So I'm going to say episode 3. So now I have created that branch, but I'm still going to work on master, because all I really want is a branch that starts episode 3, so anybody can actually go into this branch and see what the code looks like before we started working on the code. So I'm going to go ahead and close this out again, and then we'll go ahead and go into our project code. So right now in our src file, we only have one package, and this package is actually something that's accessible through the API, and people can get to it. Well, we don't want anybody to actually be able to get it into our data access object. So what we're going to do is we're going to create a new package, and this new class will hold our data source. So we'll go ahead and highlight the src folder. We'll right click, we'll go to new, and we're going to create a new class. Now instead of actually putting it into this package, we're going to define a new package. So we'll say com YouTube, but instead of saying rest, we don't really want that in that package directory, so we're going to say DAO instead. And then we're going to say Oracle 308 tube, and then we'll select finish. And there we go. Now you'll have two packages. So one of them will say rest.status, so that's the one that we can actually access through an HTTP request. And the other one will say youtube.dao. Now for those of you who aren't used to Java, these dots actually symbolize a subfolder. And what do I mean by that is I can quickly show you. So if I go to where this project is saved, you'll notice that I have my com.youtube.rest, which is the project name right here. So if I go into this and I go into my src folder, which is defined right here, what you'll find is I'll have com, and then I'll have YouTube. So what you see is that every single time there's a dot, it actually means I'm going into another subfolder. And right here, what you'll see is a split, because here I have rest, and up here I have DAO. So if I go into the rest, it'll go into the status, and that will be where my first .java file is, which is where my class is. So now if I go back, if I go into my DAO folder, this is where my Oracle 308.java is. So these dots actually are a way for you to organize where all your Java files go into. So, well, go ahead and close that out. And then let's go ahead and start defining what our data access object is going to be. So the first thing we're going to need to do is we're going to have to import in some library files. So we'll say import, we'll say java x dot naming, and then we'll just select the first one right here, double click, and then we'll say import again, and then we'll say java x dot, this time we want the SQL. We'll just double click on that again, and that'll bring both of these library files into it. You'll notice that right now we'll get warnings because we're not actually using that library file. It's just a way for you to save resources. If you're not actually using it, then you can actually delete them so that you can save resources. So after that, what we're going to do is we're going to define some static classes. So we're going to say private static, and what we're going to define here is a data source. And then we're going to name it. We're going to say Oracle 308 tube, and then we'll just set it to null. And then we're going to do another one. We're going to do another private static, and this time we're going to say, so we're going to say context, and then we'll just use the word context as well for the name, and this one will also be set to null. So what we need to define next is a public method which other methods can call in order to get that data source. So we're going to go ahead and say public static, and we're going to be returning a data source, and then we'll be naming this method Oracle 308 tube con, and then open and close parentheses. We won't be passing any parameters, and then we're going to have to say throw, and then we're going to have to define an exception. And then what we're going to need to do is we're going to, since we're going to be catching for exceptions, or we're going to be looking for errors, and to be able to handle them, we're going to have to say try, and then we're going to have to define a catch. And then in the catch, we're going to say exception, and then we'll define that as E. Let's see what I made a mistake on. Oh, I need to add a return. So let me quickly just do that. We'll say return, and what we're going to be returning is this data source right here. So I'll just copy that. And there we go. So right now we have no errors. So let's just go ahead and go through what I just did. Right now I have two private variables set up here, and I'll explain what they're holding once we get into more coding. And then we have this public method. And what's going to happen is that other methods are going to call this method in order to get the database connection so that it can actually get data from the database. And when this method gets called using this name, it's going to try this code in here. If this code fails, it will go into this catch clause. And in here, we're going to have to handle the error gracefully so that, you know, the user knows what's going on, and hopefully we capture some information to help us troubleshoot what happened. But if everything goes well, what we're going to return is this database connection, which this variable is going to be holding. So let's go ahead and define what we're going to do in our try clause. So this is the code that we're actually going to put into our try clause. So what we first do is we define an if, and we're going to say if context equals null. So context is here. So the first time this runs, it's always going to be null. We're going to initialize a new context. So we're actually going to be using this library file right up here to initialize a new context. And then in the next line, what we're going to say is Oracle 308 tube, this data source variable. What we want to do is we want to look up 308tube.oracle. Remember, this is what we defined in our WebLogic server. So this is the Gendy ID that we defined. So this ID, we're going to go ahead and look it up. So this is what we do with context, is that we're going to say, hey, go to WebLogic, look up this ID for me, and if there is a data source in there with this ID, go ahead and save it into this variable, which is what our data source variable name is. And then what we're going to do is we're going to go ahead and return that data source to whatever method called this method. That's actually all the code we need in order to look up the database connection from WebLogic and bring it into our code so that we can use that connection. But we can actually make this code run more efficiently by doing one more thing. So what we're going to do is we're going to add another if condition. And what we're going to say is if this is not equal to null, then go ahead and return what's already there. Because if you think about it, the first time this runs, it'll go into this statement, context will be null, so we'll initialize a new context. We then look it up in our WebLogic server and we return that data source to this specific variable. So if another method runs after the first time, this already contains that data source and context already has that lookup. We don't really need to run this part again. We already are holding this in these private variables. So what we say is, if this is not equal to null, then obviously we already have that connection. Go ahead and return it. We don't need to run this again. That would be just inefficient and it just won't be needed. It's also the reason why this is a static method and these are static variables. It's because we only need one instance of this class running. So in other words, if this method gets called 10 times, we won't have 10 separate instances of this method and these variables. We'll only have one because we only need one, because every single time this gets called, it's not going to change. As long as we have this connection and it's not null, we know that it's going to be holding the proper connection and we can just return it to whatever method calls it. That's basically all the code you need in order to actually return the database connection. The last thing that we need to do is we're just going to have to put something in here in our catch clause. And I'm just going to do a print stack. Obviously, if this was actual code that was going to go out, you would have something that will capture the error and also somehow return an error to the user. But for our purposes, we'll just do a simple print stack. So now all we need to do is we'll go ahead and save this. We can close this out, and then we can go back to our status. And now we're going to create a method that will actually use that connection to return some data, and then we'll output it out to the users. The first thing what we're going to need to do is we're going to have to import in some new library files. Now right now we have the core and specifically the media type imported in. So what I'm just going to do is I'm just going to replace this with star. So I'm going to import in everything inside core. Then I'm going to say import Java. It's not Java X this time, just Java and then SQL. So just remember there is no X behind this one. And then I'm going to import in this package that I define my own method in, because I'm going to need access to that method inside this class. So I'm going to say com.youtube, and there's the method. So I'm going to import in that DAO file that I had, which I defined in here. Those are all the library files that we will be needing. So let's go ahead and scroll all the way down. And what we're going to do now is we're going to go ahead and create a new method inside this class. So just create some room, and the code that I'm going to put in here is just a very generic method. So this will be another public method. It will be returning a string, and the method name that I have used is return database status. Again, we're going to be throwing an exception, and right down here, as you can see, I just did a simple stack trace. Again, just for our purposes, the only thing we're going to need to see if we have an error is just to output it to our console down here. And right now we don't have anything in the try, and you'll notice that we have a new clause called finally, and I'll discuss that as soon as we start putting some code into the try clause. You'll notice that we're going to have some predefined variables already. We have a prepared statement, and what this is a precompiled SQL statement. So what we're going to do is we're going to be writing our own SQL code, and then we're going to be sending that to the database and then having it return data. We're going to be defining two strings, and then we're also going to have a connection variable. And this is what we're going to use in order to save that connection that's coming from our own DAO method that we have defined. So let's go ahead and start putting some code into this try clause. So what I'm going to be typing in here is we're going to get that database connection from our DAO package. So we're going to say con equals, and then you'll see Oracle 308 tube. That's actually the name of this Java file right here. So Oracle 308 tube. And then we're going to be calling the method that we defined in here. So if I open this back up, here's the method name, Oracle 308 tube con. That's what that's the method that we want to call. And then we want to say get connection. So what this will return is our database connection. And then from here, we're going to use our query variable, which is our prepared statement. So in here, we're going to say con.prepared statement, and then we're going to have this simple SQL query. And all this does is it returns the date time from our Oracle database. We're not actually sending any variables into our SQL query. This is all hard-coded, and there's no way to actually inject anything or to break anything so long as the query is correct. Once we have defined this query, we're going to use the execute query, and then we're going to save the results into RS. So we have result set, and then we're going to save all of it right here. So once we have the result set, what we're going to do next is we're going to go ahead and loop through this result set right here, and we're going to save whatever we get from this date time into the string. So that all it does right here is loop through the result set, and since this is only the date time, there should only be one row, so it should only loop through once, and then we'll save it into this string. And then what we're going to do is we're going to go ahead and close this connection. And this is actually a very important step. You always want to make sure that you close your connections once you're done, because your database can only hold so many connections, or your WebLogic server can only hold so many connections. If you never close them, you're going to top out, and then your your WebLogic server or your database won't be able to have any new connections coming in. So basically, it becomes useless, and you're going to get a lot of calls, and there's going to be a lot of people mad at you. The last bit of code that we're going to do is we're going to use our return string. So we used our myString to save whatever came out of our record set, and then we use the return string, and we will make a string that we're actually going to return back to the user. So the last thing we need to talk about is this finally clause. And this is a very important clause because we're actually we're holding a database connection. So if you look at this, right up until here, we have returned data from the database, but our connection to the database is still open. While we're still doing this loop, our connection is still open. It's not until this point that we actually close the connection, and we always have to expressly close the connection. So what were to happen if somewhere between here and here we get an error? If we get an error and then we come down to the catch clause, we will never hit this clause or this command to close the connection. And what would happen is that it would stay open. What the finally clause does is that no matter what happens in here, even if there was an error and it goes into the catch clause, it would still execute the finally clause. So in other words, no matter what happens, whether it goes down the good path and everything runs fine, or if there was an error somewhere, this clause will always run. So what we put in here is kind of like a catch-all. We want to make sure that if this connection gets defined, we go ahead and close the connection. So we're just ensuring that if we actually have this connection, if it's not null, which means it actually entered into this tried clause, that we're going to close the connection. We're being very specific, we're being very precautious that no matter what happens, we close the connections so that we are not topping off the servers, and then all of a sudden nobody can get into the database, which will cause quite a bit of problems. So this is a very, very important clause, and anytime you have a database connection in your method, you should always have a finally clause that ensures that that connection will always be closed no matter what happens. This is all the code we need in order to make this method run. But in order to make this publicly accessible, we still need to define our annotations above our method. So let's go ahead and quickly do that. So what we're going to do is we're going to use our path annotation, and we're going to say if it has a path of /database, go ahead and run this method. It has to be a get HTTP request, And lastly, we're going to be producing text/HTML. That is the last change that we need to do in order to make this method work. So let's go ahead and save this. We'll come down here, we'll highlight our WebLogic server, and then we'll do another republish. Go back to the tab, make sure it says synchronize, and then we'll go ahead and give it a try. So we can go up here, we can say localhost. So if we just do the root of our project, we'll get the README file. If we say API v1/status, what we'll get is our Java REST service. If we say versions, we'll get the version 1.1, which is what we defined in part 2. And now we're going to do database, which is what we just did. Whoops, not databases, database. And there we go. So we see database status, and then we return time string. So if I were to refresh this, you'll notice that the time or the seconds will change. And that proves that this resource right here, this specific method call, is working. So anytime now, if we call database with this URL parameter, we will get the date time. And this is actually a very useful method. In fact, this whole public class right here of status is very useful, because what happens, so let's go ahead and come up here and we'll say this is version 2 now. Go ahead and save that because, you know, we did improve it. Go ahead and highlight our WebLogic server. Go ahead and republish that out there. It's very useful. The reason why I say that is when you deploy a new service out there, there's no front end to check on whether or not the deployment was good. If you have a public class like this in which you can quickly just come in here and then you can just type versions onto a web browser, you can say, oh, you know, it deployed properly. Then you can say, you know what, let me make sure that our database connection is also good. Check in here, getting the timestamp back so I know that it's the right version and my connection to the database is good. And this is the end of today's episode. So what we've done is we've created a package in which we could have a specific Java method that will return our database connection, and then we added on to our status class in which we return the date timestamp from our Oracle database. So what I'm going to do now is I'm going to spend a little time off the air to comment my code, to update the README files, do the commit, and finally to do the tag on GitHub. And then I'll get all of that uploaded to GitHub, and you'll be able to see the code before you actually see this video. We have now covered all of the basics that we need to do in order to start creating an actual API or REST service that's actually useful. So in the next episode, what we're going to do is we're going to start actually getting real data from the Oracle database. We're going to be creating a simple search, and we're also going to be outputting all of this into JSON format, and we're going to be creating kind of like a simple front web page to actually do all of this stuff. So it's really going to be neat on the next episode. As always, thank you for your time, and to my subscribers, thank you for your support.